Let's take a look at this example. We're supposed to find the following currents, voltages, and powers. So from where I'm going to start my problem, from where I'm going to start solving my problem, you're supposed to just notice that voltage source 1, right, is connected between, let's say this is my point X and this is my point Y. And I can simply say that voltage source 1 is equal voltage across resistor R1 V1 plus voltage source 2, right? This voltage is equal this voltage plus this voltage. Now I have to find the current which goes through this voltage source. So it means I have to find current which goes through this branch and find the current which goes through this branch. So now I'm going to use the algebra in order to find voltage across resistor R1, because voltage source 1 is given and voltage source 2 is given. So what I'm going to do, I'm going to simply move voltage source 2 to the other side. So I'm going to write V1 is equal voltage source 1 minus voltage source 2. Okay, simply I solved this equation for V1. So V1 is equal voltage source 1 is equal 10 volts minus, and in this case I have voltage, right? Voltage negative 8 volts. Why is negative 8 volts? Because this is my voltage source 1, right? Voltage source 1, okay, and I'm supposed to subtract this voltage, okay? So but what I see over here first, I see negative, right? So this is voltage source 1 minus this voltage, okay? So from this we have to subtract this, so I have negative voltage over here, so this is negative 8 volts, and this is going to be equal, negative times negative gives me positive, so this is 10 volts plus 8 volts is equal 18 volts. One more time, I have voltage source 1 minus this voltage, so what I have over here, I have positive 10 volts and I have minus 8 volts, okay? This minus this will give me this, so my V1 is equal 18 volts. If you want to verify if this answer is correct, so simply this voltage plus this voltage is supposed to give me this. So I have positive 18, right? Positive 18 minus 8 volts, right? Minus 8 volts will give me 10 volts. Okay, this plus this will give me this. So now we're supposed to find the current through this resistor, okay, because we also have to find the power later on. So I1 is equal V1 over R1. So this is equal V1 18 volts over R1 8K. This is equal 18 divided by 8 exponent 3. This is equal 2.25 milliamps. So this is my current which goes through this resistor. And in which direction current is going to flow? Current is going to flow in this direction. Okay, this is going to be my I1. Okay, current is going to go like this way. Okay, by the way, this voltage source, right, is connected with this one by opposite terminal, okay? So positive goes to negative. That's why we're supposed to add these two voltages, and we are going to get over here 18, okay? So we've found I1. Next, we can find P1, because if we have I1, we can find simply P1. P1, we found, so if P1 is equal I1 square times R1, and I1 is equal 2.25 milliamps to the second power times R1, which is equal 8 kilo ohms. So P1 is equal, I have 2.25 exponent 3 negative to the second power times 8 exponent 3. This is equal 40.5 milliwatts. Okay, so this is power at resistor R1. So we found P1. Next, we can say also that we found VA, because VA is the voltage across resistor R1. Okay, VA is simply the voltage from this point to ground. So this is voltage across resistor R1, and this voltage, I can say VA is equal V1, and we found that this is equal 18 volts. Next, we can find voltage VB. Voltage VB is the voltage across resistor R2. So we're supposed to find VR2. Okay, and please notice that in this branch we do not have voltage source, we have simply two resistors, and we have voltage source connected to these two resistors, so we have voltage divider over here. Okay, so I can use voltage divider to find the voltage across resistor R2. So I can say that my VB is equal V2, and this is equal voltage source 1 times R2 over R2 plus R3. Okay, I'm using voltage divider formula in order to find the voltage across resistor R2, where voltage source 1 is equal 10 volts times R2, which is equal 2K, and 2K plus 5K is 7K. And this is equal 10 times 2 exponent 3 divided by 7 exponent 3, close parenthesis, this is equal 2.85 volts. Okay, so this is voltage across resistor R2, and this is simply my VB. Next, the problem is asking me to find VAB. So VAB is equal VA minus VB, and this is the voltage which is going to be measured by my voltmeter. VA is equal 18 volts minus VB, which is equal 2.85 volts. Okay, so I have 18 minus 2.85 volts. This is equal 15.15 volts. Okay, so this is my voltage VAB. We found voltage VAB. In order to find the voltage V3, you're supposed to realize that this voltage plus this voltage will give me this voltage, right? This is KVL. Okay, so I can say that voltage source 1 is equal V2 plus V3. So I can say that if I want to find voltage 3, I'm supposed to simply use algebra and move voltage 2 to the other side and solve this equation for V3. So this is going to be equal V3 equals voltage source 1 minus V2. Okay, voltage source 1 minus V2 will give me V3. This voltage plus this voltage is equal to this voltage. So I have voltage source 1 is equal 10 volts minus V2, and we found that V2 is equal VB, and this is 2.85 volts, 2.85 volts. So I have 10 minus 2.85. This is equal 7.15 volts. Okay, so this is my voltage V3. So next we're supposed to find the current I2. Okay, I2 is the current which will go through this resistor. So I have I2 is equal V2 over R2. I'm supposed to use Ohm's law, where V2 we found is equal 2.85 volts V2. So I have 2.85 volts over R2, 2 kilo ohms, right? So this is equal, by the way, this is also equal to I3. So I have 2.85 volts. 2.85 divided by 2 exponent 3 is equal 1.42 milliamps. Okay, so we found I2. Next, we're supposed to find I source 1. We're supposed to find the current which goes through this source. Okay, so this current, okay, because this voltage source is the strongest one, so we can say that this current which will go over here, this is my I source 1. I source 1 is going to split into two currents. It's going to split into this current and this current. Okay, so I source 1 is equal, I can say I3, okay, I2, 3 or I3 is the same, so that's why I'm going to just I3 plus I1, okay, because in this branch I'm going to have current which is called I23 or I2 or I3. In this branch I'm going to have the current which is called I source 1 or I1. So sum of these two currents will give me current I source 1. So I3 is equal 1.42 milliamps plus I1 we found is equal 2.25 milliamps. So this is equal 1.42 exponent 3 negative plus 2.25 exponent 3 negative. This is equal 3.67 milliamps. 3.67 milliamps. Okay, so we found the currents. Now we're supposed to find the total power. Okay, so because we have two voltage sources, we're supposed to find the total power at each resistor. So I can say that my P1 is equal I1 squared times R1, where I1 is equal 2.25 milliamps to the second power times R1, which is equal 8 kilo ohms. So I have 2.25 exponent 3 negative to the second power times 8 exponent 3 is equal 40.5 milliwatts. Next, I'm supposed to find P2. P2 is equal I2 square times R2, which is equal, I2 is 1.42 milliamps to the second power times R2, 2 kilo ohms, and this is equal 1.42 exponent 3 negative to the second power times 2 exponent 3 is equal 4.03 milliwatts. Next, we're supposed to find P3. This is I3 to the second power times R3. This is equal, the same current, 1.42 milliamps to the second power times R3, which is equal 5 kilo ohms. And this is equal 1.42 exponent 3 negative to the second power times 5 exponent 3. This is equal 10.08 milliwatts. 10.08 milliwatts. Next, we're supposed to find the total power. Total power is going to be basically the sum of all these powers. So P total is equal P1 plus P2 plus P3. Remember, write formula first all the time. So 40.5 milliwatts plus 4.03 milliwatts plus 10.08 milliwatts. So P total is equal, we have to add these powers together. So we have 40.5 exponent 3 negative plus 4.03 exponent 3 negative plus 10.08 exponent 3 negative. This is equal 54.61 milliwatts. 54.61 milliwatts. If you use different way to solve this problem, your answer could be a little bit off, but if the values which you got are close to mine, it means that you did everything correct. So now we can say that the problem is solved.